I wrote an effect project. It was pretty bad, so I brought in a master here, Ethan. If you're not following him already, go check out his YouTube channel. It's fantastic. And we're going to be talking about the project I built, everything I did wrong, and kind of go over what real good effect code looks like. So, Ethan, let's get started.
Yeah, so I mean, I think this was a great kind of first intro into Effect, and I think there were a lot of concepts that you were really starting to get a hold of. But I think there were a couple of things that I wanted to look at in some of the original code that maybe could be optimized, and then we can look at my refactored version and kind of talk about some of the things I did a little bit differently.
Pretty much what I ended up building here is obviously in Theo's YouTube channel, we are constantly shipping videos, and to the point where like it's hard to even keep track of all of them. The point of this app is so that every time we switch a video in Notion to published, we get a notification in Discord. So basically what we're doing is we're reading from the Notion API, checking if there's some new data, and then sending that via the Discord API. And I wanted to use Effect to hook all this together. If you're not familiar with Effect, I do think actually it's worth going over real quick here the very basics of it, which Effect is often made up of these effects, which are just functions with three return types. The first one is the success type, the second one is the error type, and the third one is the dependencies type.
So Effect is like a lot of things, and it's actually quite hard to describe. I would say um, the core parts of Effect are one, this like kind of structured concurrency runtime. So you like describe your effects as this kind of like it's almost like an embedded DSL where you build up your program as this like tree of effects. And then the effect runtime runs these effects in certain ways and gives you certain guarantees and certain features. And then effect also has a kind of very large standard library of different modules and data types that are like interop with the kind of effect runtime stuff very well. But those can actually be used separately, and everything else can be tree shaken out. That's just like one way you could use effect. But the key parts of the runtime that are the most important features are the concurrency handling and the error handling and the dependency injection. So when you look at an effect type, so we're just looking at like the main effect, and you can think of this kind of like the main function. As Ben was saying, there's like three type parameters. So there's the return type, which in this case is never, and that would imply that like this effect never returns, it runs forever. Then we have error, so this effect could error with an error type, and then we have never for the dependencies, and we'll talk a bit about what the dependencies mean a little bit later because you don't use any in your first version of the app, but I do later on in the rewrite.
Yeah, so all of that out of the way, start with the index.ts. Is this my version of it or your version of it?
Yeah, so we're looking at your version right
Okay.
now, and I think I wanted to start with your version, kind of going from like the entry point
Hmm.
and then kind of like spreading out. And then with my version, I was thinking we could kind of start at like how I rewrote some of the lower parts and then come back
Yeah,
to the
perfect.
entry point. So the whole like main loop here is we kind of like do this get videos not sent, which is kind of like the core logic,
Hmm.
and then we kind of run this on this like repeat forever.
Hmm.
The like first thing right away that I see that could be changed here is kind of using like this like set timeout in this way to do like a retry.
Hmm.
Effect actually has a combinator for this. It's called effect.retry. And effect.retry, we can just take any effects. We can take like main, for example,
Hmm.
and then we can provide it a what's called a schedule. So Effect has, here we could just get like a basic schedule. Effect has this whole data type called schedule, which is super, super
Hmm.
powerful. So you can define a schedule that runs like 10 times in a row. You can define a schedule that is spaced by 100 milliseconds apart for the first 5 times and then goes to like exponential back off after for the next 10 times and then it stops. And so here we could do like, yeah, schedule.spaced takes what's called a duration input. So you could
Hmm.
like just say like 1 minutes. And this is actually like type safe. Like if I
Oh, wow.
misspell minutes, it's going to let me know. Um, but Effect also has this whole type called duration. And so duration, we could say duration dot like minutes, 60. And so duration is a type that there's like constructors for like duration dot seconds, milliseconds, minutes, hours, and then given a duration, you can convert it into all of those units. And so you kind of have this like common duration type, and there's a bunch of functions. There's like duration dot like greater than or less than, yeah, a bunch of like really cool stuff. This is like a really good example of like this is the kind of thing that
Hmm.
would be really hard to do without effect, right? Because effects are values, we can operate on values a little bit different than kind of other things. So if this was just like a function, we could call that function again, but
Hmm.
because effect is like a value, we can build on it with these combinators and pipelines
Yeah.
in really cool ways. And effect.retry is one of them. So that was something I pointed out here.
Yeah, I mean, well, one thing you just poked on there is the idea of how functional this is. I've heard effect referred to as very heavy in the functional programming world, and having worked with even a bit of effect, that's absolutely sure. I mean, you can see what Ethan's doing right here. The pipe argument is very functional programming. Taking the first effect, piping it into the second effect, and effectively, so what it looks like you're refactoring here is just now we have our generator function here, which I think going over generator functions might actually be useful. Yield is effectively a weight and it kind of works, but there's probably more to it than that. But right there, you basically just started your sending and then you pipe that into an effect that repeat, and then now it will be repeated every 1 minute. And then we run the
Yeah.
promise, and yeah.
Yeah, exactly. I think talking about generators for a second. So generators are basically, you can think of it exactly like async await for effect. So
Hmm.
just like how with a promise, you can do promise.then, promise.then. And actually, like really no one writes code that way anymore.
No.
Async await is the exact same way. So like you can think of yield just exactly like await. So we can like
Hmm.
const, something equals yield. And so whatever this returns, like this returns void, but if it returns something, this would be the type of void. So just like how await unwraps a promise, yield unwraps an effect. And the one other thing that's really, really cool here is you'll notice that this effect has this like error type of error.
Hmm.
And even though there's no kind of type annotations anywhere here, main, the like error type gets automatically propagated
Hmm.
through the generators. And this is really powerful. And we'll see this a little bit later on in my rewrite, that because the typed errors are just built in and they like are inferred so well,
Hmm.
that if you just have the type errors where the errors are created, even if you don't handle them at all, they'll just keep bubbling up and they'll all be tracked completely in the type system the whole way through your program.
Gotcha.
Okay, so I think now we can move on to this like end.ts. And
Hmm.
so this file here, we can kind of go into main real quick. So yeah, index calls this get videos not sent,
Yeah.
which is in main. And then the first thing it does is this get end variable. This is definitely like a way to do this, right? So it kind of gives you a bit of an insight into like the like most basic effect constructors, right? So we
Hmm.
can create an effect that always fails, and we can create an effect that always succeeds.
Hmm.
And oh, the other thing I guess to point out is that if an effect you only see like one type parameter,
Hmm.
it's because the others like default to never,
Yeah.
right? So if it's just effect string, it's actually effect string never never. But actually, yeah, effect has this whole module called config. So you can like, there's a bunch of them. There's like config.number, config.string, and these represent like different data types. But we can call like config.string Discord token, and what we get back is an effect of or it becomes an effect if we here. Config.string. And so this would give us the value of the environment variable. But the one thing that's really cool about this is, and this will kind of get into the dependency injection,
Hmm.
is that the way the config module works is that it reads from this config provider service.
Hmm.
And so the reason that this like effect here, if we like doesn't like, it has this requirements type of never,
Hmm.
but it actually implicitly depends on this config provider service. But there's a
Okay.
couple services in effect that are like default services. So they have default
Hmm.
implementation. So an example is there's like a console service, which is backed by console.log by default. There's a clock service, which is backed by like set timeout kind of stuff
Okay.
by default. And then there's a config service, which is backed by like reading operating system environment variables. But
Gotcha.
what you can do is you can provide custom config providers. So let's see, config provider dot from map, and then we can give it a new map.
Oh.
Let's see here. We need to here dot. There we go. And so what this would
Nice.
do is this variable would result in this value. And but
Hmm.
there's a bunch of other like config providers. So you can, again, there's like a default one like from JSON, from environment, but in
Hmm.
theory you can make your own that like makes a like fetch request, for example, to some external API.
Okay.
And it's all externally injectable. The other thing that you can do is there's like a config provider dot I think it's nested. All of your like config like kind of requests,
Mm-hmm.
you can basically externally make it that they're all like prefixed with a certain name.
Okay.
Or you can make it so that they're all like converted from uppercase to lowercase or
Mm-hmm.
like camel case, all that stuff.
I was gonna say the default provider on config here is that the .env, the environment variables?
It doesn't
Or
read from .env, it reads from like the operating system process environment
right.
variables,
Okay.
which like most runtimes will like automatically inject for you.
Okay.
Or you use like .env, like the .env package, right?
Yeah. Did you end up using that?
I don't know what actually injects them. Maybe like Railway does it, like when you
Yeah.
deploy.
In prod,
Um,
I know that they're just deployed. It's just in dev where it's annoying.
I didn't
Um.
end up running in dev because I don't have the like
Oh. Okay.
Notion token. So,
Gotcha.
but yeah, I mean, all the code is like basically the same. So yeah.
Yeah.
Okay. So next I wanted to look at yeah, this big main function.
Yeah, absolutely. I think, and I actually had very direct questions on this, so this will be
Yeah.
perfect. So obviously, right up at the top here, I need to get the Notion database ID and the Discord channel ID. So I'm yielding an effect that we just looked at to grab those. Then I need to create my Notion, Redis, and Discord clients. First question for these 5 lines. None of these depend on each other. Is there a way to run those all at the same time? Even if you want to, if I assume we're going to break this structure, but if you wanted to keep this structure, can you run multiple effects at once?
Yes. The one thing that was, I'm pretty sure all of these are like synchronous. I think the Redis one might be slightly asynchronous, but one of the things that Effect helps you to manage concurrency,
Mm-hmm.
but it doesn't like change the way JavaScript works. So right, so if like Notion, I think yeah, you're just synchronously like creating a
Yeah.
new Notion client. So even if the way you would do this, is you could say like const Notion Discord, um, and these would be equal to effect.all.
Okay.
And so effect.all is a
Oh, it doesn't have
because it's
it's not
here.
create. Yeah.
There we go. And then effect.all has a second argument. By default, it will run them like sequentially one at a
Mm-hmm.
time. But there's this concurrency argument, and so you can either set it to unbounded, which will run like as many as you give it,
Mm-hmm.
or you can set it to like a number. So in this case, it
Okay.
would limit the concurrency to it would say like just these two, and
Mm-hmm.
then when one of them finishes, it will run this one.
Gotcha.
But because again they're not asynchronous, then it wouldn't actually make that much of a difference. So,
Yeah.
yeah.
That makes sense. Okay, cool. Then after that, we're grabbing some videos out of Notion. So we're grabbing the most recent published videos effectively. Then we're checking whether or not those have been saved into Redis because we need to know if we've already sent the message. And then if we haven't sent the message on those, we go ahead and send the message. That's really all there is to this. It's not a particularly complex program, but there's definitely just some stuff here to go over with how the effect is being used for sure.
Yeah, the things that I wrote down for this file are um, one, so don't create the dependencies in line. And we're going to talk about like dependency injection and the
Okay.
way Effect does that in a super like cool and type safe way.
Mm-hmm.
But the downside of this is like, let's say you want to change what is backing the Notion client, like the
Mm-hmm.
interface stays the same, but what's backing, well, now you have to go into this function
Mm-hmm.
and like change what this means.
Yeah.
Um, but the whole idea of dependency injection is that we can just get a Notion client
Mm-hmm.
and we just say like, okay, you need to give me an implementation at some point before you run the program.
Okay.
And then this function, all it says is I need a Notion client. And then higher up, you can kind of inject different Notion clients. This
Okay.
is really, really important for testing. So we'll take a look at what that looks like. The other thing is this like has key. I mean, this is like a pretty innocent function, but Effect has this whole module called predicate. This is like one of the
That's what
modules
that
that
is.
is like a completely separate from like the Effect runtime, and there's like Effect data types, but you could like use this module and
Mm-hmm.
nothing else of Effect, and like, it's just like a bunch of functions, but there's like a
Mm-hmm.
bunch of like is date, is number, is null.
Oh,
Anyways,
has
there's one called
property.
like yeah, called has property. um
Ah.
there's like cool combinators in here. The next thing is a lot of these console.logs can be replaced with effect.log.
Mm-hmm.
So there's a default effect.log, and then there's um, different like logs. So there's like
Mm-hmm.
log debug, log error,
Yeah.
log fatal, log info. And so the like current log level
Mm-hmm.
is stored in what's called a fiber ref, and you don't actually know what that need to know what that means.
Yeah.
But all you can know is that like at different points in your program, you can set the current log level.
Okay.
So again, you can just like have a function, and it can have like 10 debug logs,
Mm-hmm.
2 info logs, and like 1 fatal log. And externally in your program, you can set like a global log level, or you can say like just for this function, set the log level.
The level would be like debug or info or whatever. So it picks which one of those it does, or
Yeah,
what does the
yeah,
log
we
do
can
differently?
actually here. Let's see, effect dot provide logger dot with minimum log level. I think we just there we go. So that's what this would look
Okay.
like, and you can change this again. There's like trace, none, info, fatal, error, debug all,
Mm-hmm.
and just like how I mentioned the like console like service
Yeah.
um, is there's also a like logger service,
Mm-hmm.
and that's completely injectable. So there's like a default implementation that writes to standard out,
Mm-hmm.
but you can there's like this logger, and we can like look at what the like logger interface actually looks like. Yeah, it just has this one function called like log, which has some
Okay.
options
Yeah.
to the output, and so you can write literally anything that matches this interface, and it will and inject it, and your program can use it. The one final thing here is these like casts. Um,
Mm-hmm.
so Effect has
Oh
its
yeah.
own like schema library called schema. So this is like Zod,
Oh wow. Okay.
and it's actually really powerful.
Yeah.
And I'm the biggest thing that schema does, which almost no other schema library does, is it does both encoding and decoding.
Oh
So all
shit.
the
Okay.
schemas are two-way schemas.
Gotcha.
And so we can look at this in a second. So here, if we look at like the Redis function,
Yeah, this one is not that complicated. It's basically just at the top we have a function to create a Redis client, and then we have a couple functions to interface with our Redis DB. So like saving video is just doing a Redis set, it's a KV store, and then get published videos is just doing a query out of Redis. So nothing really too interesting in here.
yeah, the one thing I want to point out is this like JSON stringify and JSON parse.
Mm-hmm.
So we have this like video data type, which is
Yes.
just kind of like defined here, and then we do this cast. And
Mm-hmm.
so something that we'll see is we're going to use schema on this in the rewrite.
Okay.
And something really cool about schema is because like all schemas have these like two-way definitions,
Mm-hmm.
that you can have schemas that are serializable for types that wouldn't normally be serializable. So
Gotcha.
there's a type, for example, like a date or a set,
Oh, there's
right? So
dates
these
in
are
there. Okay.
things, yeah, that like, but because it's like fully customizable, you could do this for literally any type. But there's like
Yeah.
default ones. So if if you don't know, like if you JSON parse, JSON stringify a date,
Mhm.
you won't get a date back. You'll get back a string.
It's
And
very annoying.
so it is very annoying. But so schema has like a here we can actually like look at what this looks like. So schema date date. And we can look at here if we look at const date equals date, and then
Mm-hmm.
type one equals schema dot type. So you can see that here this is date. So this is like
Mm-hmm.
the type of the output type of the schema, but the encoded type is a
Yeah.
string. So
That's
this is a
nice.
schema that knows how to go from string to date and back and forth. And so you'll see later that like again for this like schema, it's not very complex.
Yeah, but in
Um,
a real project, that would be a godsend.
so this one, there's not too much else going on here. The only thing is, again, talking about like setting this up to do dependency injection.
Mm-hmm.
And then the other thing is not doing this. So this is like the
Yes.
biggest effect sin. The biggest effect
Okay.
sin is running an effect inside another effect. So the whole way, like you like build up these effects in your program,
Mm-hmm.
and but the way you actually like get the effect to do anything is what's called like running it. So
Mm-hmm.
if you saw like back in our index, we like have this effect, and
Mm-hmm.
then we run promise, and that's what actually
Yeah.
runs it.
So we want to
Um,
just keep generating in all of these. So like in here, because like I need to run that get environment variable, but I'm in like an async promise world. That was something I was like, how should we change this to still work within the parameters of it being an effect.promise async call thing here? Or does that still just work?
you want to make your effects very like fine grained.
Mm-hmm.
In the sense that like there's this thing called effect.promise. Effect.promise allows you to like create an effect from a promise.
Yes.
Um, and like when you're starting out, like if your entire program is promise based, right? You can just wrap your whole program in effect.promise. But ideally, you want to make your like base effects as small as possible, and then make the rest of your effects these like combinations or these like compose effects.
Yeah.
But in order to compose effects, your initial effects have to be very small to like build up these bigger pieces. So the main way we compose effects is with effect.gen. And so we can say here, and we can do effect.promise. So this is what that would look like. The one other thing to note here is that effect.promise assumes that the async function you pass to it will never reject.
Okay.
And that is almost all the time not true.
Yeah, especially for like a database call. So you use
for most stuff.
Yeah.
So there's this function called try promise, and basically,
Okay.
one of the really important parts of effects error handling is that there's this distinction between expected errors and unexpected errors. So expected errors or unexpected errors, like a good example is like a panic and go.
Yeah.
Right. So there's like the normal error handling, you like return an error from the function, and there's like a panic, which is like the whole process,
Yeah, it's done.
like the whole stack is unwound, like we're done.
Yep.
Right. And so with promise, like just normal promise, it returns an effect, and we can like look at this. If we don't yield this, it returns an effect that has an error type of never. And that's because if the promise rejects, it becomes a panic, or what's called a defect.
And then it'll explode the whole program.
It will explode the whole program.
Okay, that's good.
Like, and there are ways to recover from it, but yeah. And so, but try promise. So try promise, it will, if we get rid of this, it will wrap any error in this unknown exception. Okay. And so now we have no clue what the error is, right? Because promises, the errors aren't typed.
Yeah.
But at least it's like tracked in the error channel. And then the one other thing is try promise has this like overload where you can like try, and then it's like new promise, and then there's this like catch function.
Yeah.
And so if we look at like the result of this, because we've like told it what the error is, then
it has the type.
It's typed. It's not just this unknown exception.
Gotcha. And then the way you get that catch statement to fire is you throw anything within that try promise, and then it will do that catch.
Yeah. So this function, it's a function that returns a promise. If that promise succeeds, then this whole effect succeeds with that value. And if the promise rejects, then whatever is rejected, which is unknown, gets passed to the catch function, and then the output of the catch function becomes the error result of that effect.
That makes sense.
And then I think the final thing is, so Notion, I think more of the same. Again, dependency injection, don't run inside effect. But this one, I mean, it's like very, very kind of basic stuff going on.
Yeah, it's just a database query. This is definitely something where I think the error handling on this should definitely exist, like getting some, but I think you did that in the rewrite, so we'll deal with that then. Then the way to refactor this would be to turn this into a generator function, yield the getEnv variable up top, and then wrap the bottom in an effect.promise as was done before.
Yes.
Perfect.
Yes. Okay. Do you feel ready to move on?
Let's do the rewrite.
All right, so now we're looking at the rewritten version, and I actually want to start kind of at the like leaves and then work back up to main. So starting with Redis, there's kind of a lot going on right at the start here, but this is the basis of the way that effects dependency injection works.
Okay.
So the first thing we do is define this like custom error type. And defining custom errors is really, really common in effect because errors are tracked on a type level. So the finer grain error types we can have, the finer grain our error handling can be. So a lot of error handling just ends up being like inspecting this like opaque error type and looking at the message. That's really not ideal. And so if we can have like a Redis error or a like very specific like user not found error, and on that like error object, there's like the user, right? And so having really, really specific error types is really good. So this is a pattern, like we're going to have our own Redis error and a Notion error and a Discord error. The other thing that you'll see is very common in effect is this like class pattern. So we extend this like class. It's like a function that returns a class that we like extend. So this function is called data.taggedError. And this like tag, so this is like in effect, you'll see that like if I like create like a error, just say new, then error will have a tag. And this is really important because this is how like on at runtime
Mm-hmm.
and on a type level, we can like tell TypeScript like, oh, okay, I've checked that the tag is this value, so I
Yeah.
know that this error is this type.
Okay.
And basically everything in effect has this tag field.
Mm-hmm.
So at runtime, we can tell the type of basically anything in effect by checking this tag string. And then the other thing is usually when we're interfacing with non-effect code, we want to carry along the original error, right? So if we
Mm-hmm.
don't have this cause, it's like, okay, we had a Redis error, but like, what was the actual Redis error?
Yeah.
Like,
Yeah.
no
Yeah.
one knows. So when you're interfacing with non-effect code, really, really good pattern to keep like a cause around. So next thing we're going to do is define the type of our like Redis service.
Mm-hmm.
This is again completely separate from the implementation. It's just when we kind of get the Redis service, what is the type of that service?
Yeah.
And then later on, we'll like create ways to like create instances of that service.
Mm-hmm.
So this pattern, I'm gonna call it like the use pattern.
Mm-hmm.
And this is a way of like wrapping non-effect things in effect. Um,
Gotcha.
you could imagine like we could create our own like called like it's like effect Redis, right? And it's gonna have like a get, and this is gonna like yeah, right, like this.
Mm-hmm.
Um, it's gonna return a string, and then right, and we could like theoretically do this for like every command.
Mm-hmm.
Um, but that's kind of a lot of work.
Yeah. Not
One to write
great.
out that type, and then to like implement that.
Mm-hmm.
So a really common pattern when you're just starting out interfacing with non-effect things is this like use pattern. Just to quickly like look at like what this looks like. So like right here, we like call client.use, and we'd have a function that like gets the client
Mm-hmm.
and then uses the client to like do something.
Ah, okay.
So within that function, we can basically use the client like normal.
Okay. And is
Um,
that like a normal asynchronous function within that .use?
yeah. So the way it works, here we can look at like, all right, there's kind of a lot going on here, but
Stick with the use and just like,
so right here, when we're
Mhm.
calling use,
yeah.
what this is doing is first, this like, and we'll talk about what this means in a second, but we're getting the Redis instance from the context. We're like
Cool.
requesting Redis from the context. So
Yeah.
then it gives us this like Redis impl, which is that type we defined earlier.
Mm-hmm.
And then when we call use, we're just getting access, like temporary access to the like inner client that's
Yeah.
inside. Like it's like a wrapper, and then we like are able to use that client inside that function, and then what use is doing is it's like wrapping that in like effectful like stuff for us.
Okay.
So it's automatically yeah. So like this is just like some function that like returns like a promise basically.
Gotcha.
So
Okay.
we could essentially return anything here,
Mm-hmm.
and we could also like do a bunch of like really weird stuff, right? Like we could start like console logging here. We could like fetch. We could literally do
Yeah.
anything,
Okay.
right? But like in theory, you know, you just use the client, just keep it
Mhm.
nice and simple like this.
Yeah.
And then what use will do is it will like internally wrap this in like effect.try promise. And so you'll see that like what we get back here is an effect of the like result of that Redis call
Mm-hmm.
or a Redis error.
Gotcha.
Um,
Okay.
yeah.
And then that's actually a question that I probably should have asked earlier. If we get an
Yeah.
error within the redis.use and we've yielded it, does that error just like then go up a level or whatever and get passed out of the effect.gen? Like, does it just stop execution there and then returns that error from get published videos?
Yes. So when you yield
Mhm.
an effect,
Yeah.
if that effect errors, then that the entire effect.gen,
Mhm.
so this entire thing,
Yeah.
like errors, like that whole effect, because effect.gen is like it's itself one effect that's made up of like lots of little
Gotcha.
effects.
Okay.
So if any of the effects that you're trying to yield error, the whole effect.gen errors, but again, it's all type safe. Like get published
Mhm.
videos, you'll see that it like has this like Redis error in there.
Yeah.
And we can look at like error handling a bit later, but we can kind of look now. So like if we want to we can say catch tag.
Mm-hmm.
So, and you also see that like it knows the types of the errors in this function. So it knows it can only ever be a Redis error or a parse error.
Yeah.
And so we can say Redis error, and then we can handle that error with an effect.
wow.
So we can,
Okay.
it gives us the error, and then we can just choose to log it out.
Damn. And then you do the same thing for the parser.
Yeah, but if you don't, and so now because we've handled this, right?
Mm-hmm.
It's removed from the type. But if we
Type
remove
is-
this,
Oh,
it's still there. And
gotcha.
if we, let's say here, we instead of logging the error, now we fail with like a new like error, right? Like a error object. Well, now then the error is what appears in the error instead of the Redis error.
Gotcha. I see.
Okay, very very cool. All right.
Very, very cool.
So yeah, so let's talk about this. So
Yes.
this is what's called a tag. So a tag is, I like to describe it as like a placeholder.
Mm-hmm.
So a tag is related to a type and a string.
Yeah.
And so the string is what actually like determines at runtime, but like that's kind of like an internal implementation detail.
Mm-hmm.
All you need to know is that like this tag represents a placeholder for an object of this type.
Okay.
And so you'll see that in our functions, we just yield the tag
Mm-hmm.
as if it was an effect. And what this is essentially doing is it represents an effect that's like inspecting the current context, making sure that the Redis service exists in that context, which it
Mm-hmm.
should because it's type checked,
Yeah.
and then returning the current Redis implementation in the context. But like you can
Okay.
think of it as we just get back the type of the placeholder. And then when we do that, the whole effect now in this third type parameter says, hey, in this effect, you use the Redis placeholder. So you need to provide me a Redis. Like I don't even
Mm-hmm.
know what Redis, all I know is that it's a type. I gave you the type,
Yeah.
but you have to give me the actual thing.
Okay.
And so we'll see higher up in the program is when we actually like inject what the Redis
Um.
actually ends up being.
Okay. And is that what the make function is? That's the us creating our Redis instance.
Yes,
Okay.
exactly. So now if we go back, you'll see that so make is a function
Mm-hmm.
from the actual Redis client options
Yeah.
to an effect that returns the Redis impl, which is the type contained in the like Redis service, like the type of
Mm-hmm.
the Redis service. And
Yeah.
then where this comes into play is there's this type called a layer. And a layer is basically like it's a type that creates services, constructs services.
Mm-hmm.
And so where this comes in is like you'll see just a sneak peek, like in our index file, we like provide this effect provide, we're like injecting the services.
Mm.
So here we have all of our services, and then we take main, which depends on Redis, and then we provide the Redis layer.
Oh.
And then
Okay.
if we take like if we say like effect provide main all services,
Mm-hmm.
and then you'll see that like now this effect has never because we've
Mm-hmm.
like providing it removes it from the type,
Yeah.
just like how handling an error removes it from the
Mm-hmm.
type.
Yeah.
Yep. Now there's actually kind of a lot going on in this make function. So
Mm-hmm.
the first thing is this like type here. So this is just like this create client function. This is from the Redis package, and this is
Mm-hmm.
what actually creates the Redis client. And so all we're
Right.
doing is just kind of like extracting the like internal or that like this type, the type of the arguments to this function,
Uh-huh.
and making that the type of the arguments to
Yeah.
this like make function. So this part is kind of cool. There's this effect constructor called effect.acquire release.
Mm-hmm.
And this has to do with obviously from acquire release, you can tell it's like scoped resources. So
Yeah.
something that has like a defined constructor and destructor.
Mm-hmm.
And this happens all the time. And so effect has a very special like way of handling this, which is if we get rid of this yield, you can see that effect.require release. And by the way, yeah, we can just look at the acquire function
Mm-hmm.
is a try promise, which like creates the client and then connects to it.
Mm-hmm.
And then if there's an error, we kind of remap it to, and we can actually add like a message here, error connecting. And the other thing is you'll notice that like we can be like very brief in our messages because we
Mm-hmm.
like know this is a Redis error,
Yeah.
right?
It's
Like if it
gonna.
was just an error, we'd have to say like, okay, this is an error in Redis in this, but because we already know it's a Redis error because the error type is so descriptive,
Mm-hmm.
our message can be much more brief.
Yeah.
And then, yeah, the destructor function is just taking the client and then effect.promise, and this should actually be try promise as well. Or I think there's actually something where like the destructors, like can't error because where would you handle the error in the destructor? Like I think it becomes either you just like drop the error or it becomes a
Yeah.
defect.
Yeah.
But anyway, okay. So if we look at this require release. Anyways, okay, I'm just gonna. So this is
Mm-hmm.
like an effect, and it gives us like the like client, and then the like Redis error,
Mm-hmm.
and then it gives us a type called a scope.
Okay.
And so a scope is a service, but it's like a different service than every other service.
Yeah.
So where Redis represents like an actual like an actual object we have to provide,
Mm-hmm.
a scope is kind of like hijacking the dependency injection way
Mm.
of saying that like this effect has like finalizers or destructors.
Mm-hmm.
And so there's this combinator called effect.scoped. And so
Oh.
effect.scoped. And so you can see that like what this does is it takes an effect that
Mm-hmm.
may have a scope and it just removes the scope.
Yeah.
And what that represents internally is like, okay, like an effect gets a scope when something inside it has a destructor.
Mm-hmm.
And when we affect that scoped, we say, after this effect ends, run all those destructors.
Yeah. Okay.
And so that removes the scope because there are no destructors because we ran them.
Cool. Okay, so that's basically what's happening here is the acquire release effectively just means that we are creating a new, it's like a deferred function in Golang or something like that, where like it will
Yeah.
just run that when this is done being used. So that second function there, the client dot quit, that's just turning off the client when we're done using it.
Yeah. I think the one thing to like distinct, like, or make a distinction from Go is that
Mm-hmm.
in Go, it's not very customizable, right? Like
No.
defer runs at the end of the function body.
Yes.
But with effect, like you can say, okay, this effect has a scope,
Mm-hmm.
and I don't want to close the scope until like you could literally close it at the very top level of your program, right? Like
Yeah.
in main or in index,
Mm-hmm.
right here, we could do like effect.scoped, and then every single scoped thing from our entire program, if we didn't handle it anywhere else, like you could, put these effect scopes like in like lower down.
Yeah.
This would close all the finalizers of the entire program right at the end.
Okay.
So it
Gotcha.
can like it can escape the current function where like defer is very defined.
Mm-hmm.
And same with like using, right? Like TypeScript like using proposal.
Okay.
So and then yeah, we can now talk about so we like create this client. It's like a scoped
Mm-hmm.
effect that gives us this client. And
Yep.
so this like implicitly will destruct it when we decide to.
Yeah.
And then here is what the use function actually looks like. So it's kind of big.
This was the most confusing piece when I read through this code base by far.
Yeah, so if you remember, this function is a function that like takes the client
Mm-hmm.
and like the consumer like uses the client somehow.
Yes.
So first we have to get the result of running that function. So just like how there's like effect.promise and try promise,
Mm-hmm.
there's effect.sync and just effect.try. And these are for
Yeah.
like, because this function is not an async function, right? It's just a synchronous
No.
function.
Yeah.
So first we have to get the synchronous result. And again, if this is an error, we create this new Redis error. So now we have the result of this function, which
Mm-hmm.
most of the time will be a promise, right? We like
Mm-hmm.
call hgetAll,
Yeah,
right?
which
And so
returns a
this
promise.
returns a promise of this like object, right? It's like a map. So now this is a promise to that map. And then, but it's possible that there are some like methods on the Redis client that are synchronous.
Mm-hmm.
Yeah. So if it's not actually a promise, we can just go ahead and immediately return it. But if it's a promise, then we use try promise. And then if there's an error there, then that's like an asynchronous error because there's like
Mm-hmm.
two computations happening. There's like using the client to get something. And then if that something's a promise, like awaiting that promise. And so you can kind of see how like when we do this like hgetAll, right? So internally, this is calling this function with try
Mm-hmm.
and then calling this promise with try promise.
Yes.
And then
Okay.
what we
That
get back is just
makes
the
a lot of
result.
sense. Okay.
And then there's a lot of like type stuff where it's like generic,
Mm-hmm.
right? So like generic over a type, and then it's like awaited. Then we can look at again like layers is this type that like
Mm-hmm.
creates a thing. So here, this layer, you can read this as this layer constructs or like creates a instance of the service Redis.
Okay.
It could error with a config error or a Redis error,
Mm-hmm.
and it has no dependencies itself. And so you can create layers from effects, and you can also create layers from like scoped effects, right? Because this
Mm-hmm.
effect, like make, you can see requires a scope. And so what this actually ends up looking like is basically like I like to think of layers as like effects that happen like before our program. So there's
Mm-hmm.
like layer effect, and then like our main effect,
Mm-hmm.
and then the like layer destructors. So that's how like this like layer.scoped removes the scope,
Mm-hmm.
but it actually like implicitly adds it to like after main.
And you have
Um,
two layers here. What is the difference between these two? My guess here is the Freemium very clearly, that's the one you ran in main, right? Because what we're
Yeah.
doing there is we're grabbing the URL from config.string, and then we're making our, we're calling the make function, which is the one which can then do all of our Redis stuff.
So they're basically the same thing, except layer like just kind of like forwards the options to the consumer.
Okay.
Where from end, like you can see it doesn't actually take any arguments. It just
Yeah.
like this is very broad and this is
Mhm.
very specific.
Yeah.
And so for us, like we're not like there's like a bunch of options to the create client function, right?
Mm-hmm.
We're just doing the URL.
Yeah.
And so for our purposes, like this is like I left this as like an example of like a more general way. If you're like for a consumer to kind of provide whatever options they want.
Mm-hmm.
And then again, this make function is like it returns this Redis impl. So when we create a layer, we give it the tag. So we say
Mm-hmm.
create a layer that creates this tag, and then we need to give it a way to construct the type of that tag.
Yeah.
So we give it an effect that returns the Redis impl type. And then the one other thing in this one, and then we can just kind of go over all the functions, is I was talking about schema.
Mm-hmm.
So when we have this like video data type,
Yeah.
right, which is the type of the like JSON encoded string for each video that we're storing in
Mm-hmm.
Redis. So schema, again, if you've like looked at like Zod or anything,
Oh
it's
yeah.
very similar. But then there's this commentator called parse JSON.
Mm-hmm.
And so what this does is it converts this schema. You can see it's like a schema, and this is like the decoded type,
Yeah.
and then string is the encoded type.
Okay, so the parse JSON is defining the encoding, and then the inside of it is defining like the actual schema itself.
Yeah, so this is a schema, right, on its own.
Right.
And then we pass it to a function that like takes in a schema and
Mm-hmm.
returns a new schema.
Gotcha.
And it
Okay.
takes in and it returns a schema that is like the original schema
Mm-hmm.
plus this like conversion to and from JSON.
Cool. Okay, that makes sense.
And so again, I talked about like if we wanted to have like a date, we could do schema dot date, or like a set, and this would be schema dot set,
Mm-hmm.
schema dot string. And so because schema dot date and schema dot set, they like have these conversions built in.
Mm-hmm.
This would all like just work,
Yeah.
and like we would decode and encode, and we would get back a date and a set. Oh, the other thing is that I think this is because I don't know, like in JavaScript, like usually it's like camel case, and I noticed like all of your functions were snake case.
Oh yeah, I don't remember why I did that. That was a while ago. I think it was like after the advent of code elixir bender thing, and I was just
Yeah.
like, I just wanted to feel something again. But
Okay.
I just wanted the elixir back. That's all.
So something you'll notice about save video is in the original one, like the Redis client was like the first argument to this.
Mm-hmm.
But now it's not an argument. Like it's actually like a kind of this like implicit argument,
Mm-hmm.
right? Because save video like depends on this Redis service.
Yeah.
But it like that happens through like the effect dependency injection system.
Mm-hmm.
So we just take the data and then we yield the tag, right? And so this gets us back the instance of that service, and at the same time changes the result type to include the Redis type in the services type, like the
Yeah.
third type parameter. And then so schema has these functions. So there's schema.encode, schema.like decode, and then there's like decode unknown, which is like if you use like Zod schema.parse,
Mm-hmm.
schema.decode unknown is basically the same kind of thing.
Okay.
But you'll notice like here we use schema.decode, but schema.decode like expects the type, right? Because like this schema like decodes from string to this like object type.
Yeah.
So schema.decode expects a string, and then does the conversion. But schema.decode unknown takes unknown, first checks that it is a string, and then does the conversion. So yeah, a little very subtle difference. But basically, we have our data, which is like this like object type.
Mm-hmm.
And then we use our schema to encode it to the encoded type, which is a string, because we're
Yeah.
encoding through this JSON. But in theory, right, like this is actually like an implementation detail. Like this could actually be any kind of encoding from this object to this string. Right?
Mm-hmm.
Like we could base 64, we could like convert it to JSON and then to bytes, and then base 64 encode the
Yeah.
bytes, right? Like I don't even know. It's all encoded in the schema. That's what's really cool, right? Like the schema represents the transformation.
Yeah.
And then we use our client with this like use thing,
Mm-hmm.
and then I set these like I just included some logs, like all the
Yeah.
previous console logs.
Good stuff.
The other thing is there's a bunch of like telemetry stuff in effect.
Mhm.
So for logs, you can add like log spans.
Mm-hmm.
So you'll see that like log spans log out the time that span took, and then it also will like associate like logs with this name.
Okay.
The other thing you can do is you can affect like log annotations. Here a hash map of, or I think it's annotate logs. Annotate logs. And then what does this take? It's like foo bar. Yeah, and so what this would do is like every log, like inside this, because again, with the pipelines, like actually what this is doing is like effect dot annotate logs, and then it's like inside, whatever.
Yeah. Yeah.
and then this returns a new effect, right? Because they're all like the pipeline is like wrapping, right?
Yeah.
Um, so anything like before this in the pipeline gets passed to this,
Mm-hmm.
and so is affected by it. And so there's a lot of very powerful logging stuff you can do. The big thing with effect though is that like effect has like open telemetry built in. So you can like effect dot like width span, save video, and then you can provide it like yeah, attributes. It's like foo bar.
Mm-hmm.
And so this will automatically create an open telemetry span that has like the duration of this effect.
Wow.
This is really powerful because I don't know if you've ever had to use like open telemetry without effect, but you have
I
to
have
like
not.
wrap like every single function and this like tracer dot like start. It's a nightmare.
Dang.
And so effects kind of like composable way does this really cool. But because we're not really exporting the open telemetry here,
Yeah.
there's kind of less stuff like this. On the decode side, so we use the client, we get the raw videos,
Mm-hmm.
and then we decode them. And because this is like an get all, right? We like get back this object.
Mm-hmm.
It's like a map from string to the data.
Yeah.
And so we decode it with this like record type from key string to value video data.
Yeah.
And this is our schema from earlier. This is just like the same as before. We kind of go over them and return them. And then this clear Redis DB just calls flush all. Do you have any questions in this file?
No, I think go back up to the top real quick. The mental model on the yield Redis is the weirdest thing here. So right there, so const Redis equals yield Redis. And then if you go back up to the top, we have the export class Redis extends context tag Redis, and then Redis impl. And then Redis impl is basically just saying like basically my question is how does that use function that's defined in the interface get mapped to like the make function and stuff like that? Like how do these all actually get stitched together?
Yeah. So this is just a type, right? Like we can
Right.
define here. We can let's like create it's like class foo extends, and this is just going to be a string.
Mm-hmm.
And then we're going to create a new effect like const effect equals eg. We're going to say like const foo yield foo like console.log. And so we remember this is like think of this as like a placeholder.
Uh-huh.
So what this is saying is like get me the like from the current context, get me the foo, and then it gives you the string. And basically because it's like in the type system,
It's making it a
theoretically
dependency.
it
Yep.
should always be there.
I gotcha.
And then what we can do is we can like pipe this into, we can call this, there's a effect.provide service. So what we're doing is we're saying right here for the foo service,
Yep.
here's the implementation.
I
And then
gotcha.
what this is doing is there's like, again, there's like this context type, which is basically like a map
Yeah.
from these like this string to the actual type. And so what this is doing is
Okay.
it's saying, okay, for this effect, take the current context, take the string tag of this tag object and assign it this value.
Cool.
And so then here we get the context, we get the string key, and then we retrieve the value.
Okay, and then down below the make function, I think it was, like right
Yes.
below, in our layer, in our from env, that's what we're doing here, right?
So yeah, so there's like effect service. We're just like directly providing the service. But we can like say like a const like foo layer. And it's going to be like layer dot effect. And a layer dot effect just like creates a layer from an effect. And then we can say effect dot, and it's going to be provide instead of provide service. We can provide the foo layer.
Cool.
And layers are important because if you need to create a service from an effect, then you need to use a layer.
Okay.
So like in most services, like if you have like a database, like constructing the database client could error.
Yes.
Or it's asynchronous. And so if it could error or it's asynchronous, it needs to be an effect. Okay. So next Notion, this should be basically the exact same. It's a little bit different because like this is just because the Notion client is a class, we want to get the type of the arguments for the class constructor, which is like it requires this like thing, which doesn't really matter. But we do the same thing, right? This use setup, we create a new error type. We create a new class. This is all exactly the same except Notion error instead of Redis error.
Yeah.
This is all exactly the same except the Notion API key. Here, so before, again, we were just casting this away.
Yeah.
But now I like created the whole, and again, you could do this with Zod, but it's just cool because it's a fact. And here again, this isn't doing any transformations, right? Like this is just a plain schema. But what's cool about schema is like you can do the transformations if you want to.
Mm-hmm.
So here you'll see this is where we use decode unknown, right? Because we get the client and then we this was also in the original code. We get this environment variable here,
Mm-hmm.
and then we do the database call,
Mm-hmm.
and then this raw response we do decode unknown, and this is just like Zod schema parse,
Mm-hmm.
and then
Yeah.
we get this whole type response.
Gotcha.
Okay.
Nothing to
Discord
do there.
again, very very similar, just Discord error.
Mm-hmm.
The functions here basically the same. Here, one interesting thing to point out here is inside a generator function,
Mm-hmm.
if you yield an error, the like generator function like doesn't continue execution,
Mm.
right? But TypeScript doesn't know that. So this is sendable. This is
Mm-hmm.
like a function that like declares that the value is a certain
Yeah.
type. But the way that like TypeScript operates on this is if you put a return here, it knows that like if this is not true, right? So
Mm-hmm.
if it's not a sendable
Yeah.
channel and this returns, then anything below it, it must be a sendable channel. And so you have to put the return here. And actually this doesn't ever return because if you look at like const result, if you yield an error,
Mm-hmm.
it's just never, right? Because
Yeah.
yielding the error ends the whole function. So this like
Mm-hmm.
never actually returns. So we can just put the return here and that like helps TypeScript know that the function execution actually does end here. But yeah, so same kind of thing. We get the client. The way the Discord client works is like you do this like channels.fetch and then you
Mm-hmm.
get a channel back. And so one downside of this like use pattern is that we get this channel back and the channel is not wrapped, right? In the way that like the original client was.
Yeah.
So here we have to use like try promise. And again, like if you're really building out a large application, like you can write your own wrapper.
Mm-hmm.
And there's like a lot of cool stuff you could do. But this is just like, very simple. The other thing that was super weird here is this channel.send. It returns this like promise of message false or promise of message true. And that like causes some type error.
Mm-hmm.
But if it's promise message true or false, the type error doesn't exist. It's like this like unification issue.
Very
Unification
cool.
is actually a very interesting topic in effect. And that's like a really big benefit of like, if you notice all these effect.gen functions, like here, this happened in
Think
Redis
had it.
here, right?
Yep.
That they all get like combined to one effect type.
Yeah.
Because a lot of like very naive implementations, it will be like type foo equals like effect dot like effect dot effect string like or effect dot effect
Yeah.
like number. But you really want to like combine these, and there actually is a way like type foo unified equals unify dot unify foo. And foo too. Look at that. So yeah, so like then, and by the way, this there was like if you like look at this code, it's there's like a lot going on.
Oh
I
my
wouldn't even
God.
touch it.
Yeah.
Yeah.
Get real.
So yeah. And then I think we can work our way back to main.
Mm-hmm.
So main is just combining all of these. And the other thing I want to point out is that there's no like type annotations like anywhere here. Like I added a bunch of them.
Yeah.
But all these functions, all the return types, they're all completely inferred, right?
Mm-hmm.
All inferred, all inferred, all inferred. And so main is more the same, right? Like this code, like I think this code like one-to-one could run in like there's no TypeScript in this code at all, right? It's just straight JavaScript.
Yeah, absolutely.
It's super cool.
Yeah.
So we get the environment variables, and
Mm-hmm.
then this is another kind of common pattern in effect, doing these like star imports.
Star. Okay.
And this is because like in like a module, right? Like a lot of functions will be associated with a data type,
Mm-hmm.
right? Like effect dot succeed, effect dot fail. And so in the like effect module, it's just export const succeed, export const fail.
Mm-hmm.
And so when you import effect from effect, it actually like wraps that into one object. But really what this is it's like importing star as effect from effect slash effect.
Mm-hmm.
And this is the same thing.
Okay, wait, real quick. Could you hover over main? I want to see the type of this. I want to see if.
Yes, I will. let's just go over the body and then we'll look at that.
Okay, there's something that I think is in there that I want to see is in there.
So we get some environment variables, we call notion.getPublished, and we get the like decoded Notion videos. And then we go to Redis and we get the Redis videos. And then we go over the results. And again, these are not casted anymore because we did the annotations,
Yeah, you have
or
the
the like schema decoding.
much better.
And then remember, we're using predicate.hasProperty. Wow, so cool.
Very useful.
And then we call redis.saveVideo, discord.sendMessage. And then this was like before, we just repeat this every 5 seconds.
Yep.
Okay, so what are you expecting in the type of main?
Dependencies.
Exactly, right? So this like Notion.getPublished requires Notion, Redis requires Redis.
Yep.
And so if we look at main,
Hell yeah.
there's kind of a lot going on here. But this is awesome. Like this is actually really good.
Yes, this is extremely cool.
And so the reason this is so cool is because we haven't handled any errors, right? We've created a bunch of errors everywhere. We haven't handled any, but Effect has tracked them all for us, right? So it's saying, hey, it's possible there could be a config error, right? The environment variable's not there. There could be a parse error. There could be a Notion error, Redis error, right? And it's also saying, hey, you still haven't provided us these dependencies. So now in index, there's a way of like combining layers, right? So we have our 3 layers that like create Redis. And then we combine them, and then we effect.provide them, and then we pass it. The one final thing is this: instead of effect.runPromise, there's this function called node runtime.runMain. And I guess I can just touch on there's this Effect has this module called platform, which is like platform shared like interfaces with platform specific implementations.
Gotcha.
So there's like a file system, there's like HTTP stuff, socket stuff. And so you can like use the like socket interface and then provide it the like bun WebSocket implementation or the like node net socket implementation, right? But this like run main, what this does, and we can actually like look at what this does. The other thing to note is that in Effect, it's so cool. If you like command click on the functions, you like get taken to the actual like source code. A lot of them, there's like internal modules, so you have to like click one more time. But just all the source codes, right? I mean, this is kind of there's a lot going on there. But basically, what run main does is it sets up like a like sig int listener that will interrupt your Effect on like Control C.
Okay.
And the other thing it will do is it will like, so if your like Effect like fails, it will like log that out to standard error and like fail with a non-zero exit code. Yeah, but if we look at here, if we like separate this a little bit, like const main 2 equals Effect dot provide. So all the errors are still here. But this is where we can start to kind of look at the error handling. So there's like a bunch of different options. So there's like effect dot catch all. And so what this will do is it will give us this like error, and then we return here. This is fine. And so this is catching every error. So we get the type, and again we know the type of errors. And then it gives us like an effect to handle that error. So we could just log it out. We could remap it to like a different result, right? Like if you have like a database call, you can map it to a different error. You can map it to like a like kind of like default result. There's like an option type. You could like map the like error state to like the none variant of the option type. And then as I showed earlier, there's like a bunch of like other functions. There's like catch tag. So you can like handle all the different cases one by one. And again, it's very fine grained. Like if you only handle one error type, only that type will be removed from the type. But I think it's worth pointing out that like by default, you don't have to do any error handling. Like it's just like normal code. Like normal code, you don't do any error handling. Like one promise rejects, your whole thing blows up. And this code is actually the exact same. But when we want to start handling the errors, they're all still there, right? They're all still there.
I had one more main question on here, and that is, how would this look to like, just for example, say you have like a Next.js app or something like that, and you want to wrap your database logic in Effect. You want to start there. What would it look like to run that Effect code within like a server component or something like that, like get all users or something like that? What would you call effect.run sync or effect.run promise, or how would you do that?
Yeah, so I think one of the most like valuable parts about effect is its like interop story. So it's very
Mm,
easy to interop both like from like promised land to effect land and also from effect land to promised land.
yeah.
So the way you do like again, there's like promise and try promise, and so you can basically take any promise function and
Hmm.
just wrap it automatically into an effect, and whatever that promise returns will be the type. And if you don't want to do error handling, it's just like that unknown exception type.
Yeah.
Um, and then for going from effect, like let's say you want to use it again in a server component in an
Hmm.
API handler,
Yeah.
there's this function called run promise, like you mentioned,
Hmm.
and this just gives you back a. You'll see it's complaining because we haven't. It will only let you
Yeah.
run an effect that has dependencies of never. So if we
So we
type
need the
this,
type.
whatever this effect returns,
Hmm.
the promise will resolve to, and if this effect has any error, that the promise will reject with that error.
Hmm.
Um, and so if there's like just one part of your program that you really want this fine grained error handling, you really want some of the like concurrency stuff,
Hmm.
the dependency injection stuff.
Yeah.
I mean, there's so many cool things, right? But you can just like one API handler, you can do the whole thing in effect, and you can convert it to a promise and like export it, and like that can be as
Yeah.
much effect as you want to use.
Very, very cool. Wait, where was the concurrency example in here? Because that's actually stupidly useful for like if you're just fetching from two different data sources that can be non-blocking. We talked about
And
that earlier. I just forget which file it was in.
here, these two, yeah. And I actually forgot to do that. So
Oh yeah,
these are
perfect.
both
Use these as well.
asynchronous, right?
Yeah.
And so, again, there's this combinator called effect.all. And so effect.all can actually, it can take either like an array or it can take an object, which is kind of cool.
Mm-hmm.
So you can say like const notion videos, Redis videos, and we can say effect.all.
Oh wow. Okay.
And this will, it just works. But again, by default, it runs synchronously.
Mm-hmm.
And so here we can say concurrency unbounded.
Mm-hmm.
And now they're running concurrently.
As concurrent as you can get in JavaScript.
Yeah, and here, we can also do that down here. So we can say yield
Oh yeah,
effect.
saving the video and sending the message can definitely go together.
What am I missing? Oh, there.
Yeah.
Okay.
Nice.
And then don't forget,
Hell yeah.
hell yeah.
That's really
And
cool.
again, over promise.all. The other thing that this is
Mm-hmm.
doing, that like promise.all, so there's a couple things happening. So one is if one of these errors,
Mm-hmm.
by default, it will like short circuit. So this
Yeah.
entire effect will error with the first error.
Mm-hmm.
So like this effects error type is the union of these two effects error types.
Gotcha.
Um, but effect has like a very robust interruption framework, which promises don't, right? Like if
Mm-hmm.
you promise at all, then the other promises like they just keep running. And there's like
Yeah.
abort signal stuff you can do, but you like have to pass the abort signals
Mm-hmm.
and track them yourself, and it's a
Yeah.
nightmare. Um, and oh, the other thing to mention is effect.promise. In this function, it gives you an abort signal.
Oh
Um,
wow. Okay.
so like in if the effect gets interrupted, it will propagate that interruption via an abort signal to all of the like non-effect stuff,
Wow. Okay. Cool.
which is pretty cool. But so because and the other thing is like remember I talked about like scopes or destructors.
Mm-hmm.
So those will like if your effect gets interrupted, it will make sure to run the destructors,
Yeah.
which is great, right? And so that's all happening like without you even thinking about it. Is like type error handling, interruption. If you don't want that short circuit behavior, there's a couple of these like modes. So there's one called like either, which converts everyone to an either. So an either is
Oh.
like a either or data type.
Mm-hmm.
So here, every single effect gets run, and it's either the result type of that effect or the error type of that effect.
Mm-hmm.
And it's like so if one effect fails, the other one might not fail.
Mm-hmm.
And then there's one other called like validate, which does like slightly different behavior. But it's all yeah, very customizable.
Yeah.
And again, that's like stuff that's really important that if you just use promise.all, you're not thinking about. And
Mm-hmm.
to build on top of promise.all with interruption, with error handling, with all this stuff, with again the structured concurrency, where let's say we had like 5 or like 6 or however many
Mm-hmm.
effects running here, and we want to do like 2 at a time concurrently.
Yeah.
It's just super, super easy.
Okay. Well, is there anything more that you really want to go over here in this project?
The one thing I want to mention is if you're using schema, you need to use exact optional property types.
Ah.
It's just like a requirement for the way it works.
Hmm.
Um, and I think that's worth noting. Uh, yeah, I mean, do you have any other questions here?
To be honest, not really. I definitely commit the changes you made here. I will merge this
Yeah.
in later today. I want to try doing stuff. I want to take a lot of the stuff we did in here and use it within like a SvelteKit app and do stuff there, like wrap some authentication logic, wrap some database logic, make that a little bit nicer, and then might have more effect code for you to roast pretty soon here. But yeah, this was very, very helpful. Really enjoyed this. Thank you for doing this. Really appreciate it. And yeah, go follow Ethan's channel if you haven't already. He's clearly amazing, especially if you made it this far. Like, come on, what are you doing? And yeah, I will talk to you soon.